Here is grade 7, module 9, lesson 1. Our I can statement for today is I can inscribe triangles and circles and draw geometric figures meeting given conditions. So here's some vocab for us, drawing circles and other figures. So a circle's radius is the distance from the center to the edge. So the radius is the distance from the center to the edge, and that can be any part. So half of the diameter, it could be right next to that. It's any part from the center to the outside. And then our diameter is the distance across the circle at its widest point. So for a diameter, it needs to go through the center. That's going to be our way to show that it's the widest point. So it can be like that. It could even be like right next to it, as long as it goes through the center. Goes through that center point. Any of these would be a diameter. And 2 radii will add up to your diameter. And then the diameter of the circle is always twice the radius. And then our formula of a circle's perimeter is the circumference. So that is your perimeter, sorry. Perimeter is the distance around your circle. So imagine you had a string and you wrapped it around and then you laid it down and measured it. That would be your perimeter. All right, and then circumference equals pi times diameter, which is the formula for that, and we'll get into that a little bit later. A circle can be divided into 360 units called degrees. So on our circle here, we have a lovely protractor going all the way around. Here you have 0, and then each of these are little marks. So like this would be 1, 2, 3, 4, and then it goes by 5. So this would be 5, 10, 15, 20, 25, 30. If we were going clockwise, you can see you could also go counterclockwise too, as we're counting or looking at the protractor that way. But each of the marks, the medium marks here are 5, the big ones are 10, 5, 10. And they all add up to equal 360 degrees. So how we're going to use this in a problem here is we have Allie is planning a circular garden. Her plan for the garden is shown below. So she wants 20% of the circle to be tomatoes, 15% to be root vegetables, 40% for melons and squash, and then 25% for Brussels sprouts. So we first need to figure out how many degrees is 20%. So looking at our 360 degrees to go all the way around our circle, we need to figure out what 20% of 360 degrees. So of in math land always means multiplication. So let's change our percent to a decimal. So 0.2 times 360 degrees. Pause your video, multiply that out for me, unpause it when you are good to go. And then this is going to be for tomatoes. So tomatoes are going to be 72 degrees. So I'm going to add that underneath here. And then we're going to do the same thing for root vegetables, melons, and squash, as well as Brussels sprouts. So we'll have 15% of the total, so of that 360, so 0.15 times 360. Again, pause your video, play it when you have that multiplied. It's going to be 54 degrees. Be careful with that decimal in there. And then do the same for the other two. Pause your video, unpause it when you have melons and squash, as well as Brussels sprouts done as well. So melons and squash will be 144 degrees, and then 90 degrees. Oh, that's percent. 90 degrees for Brussels sprouts. Okay, and then if you always want to check your math, the way to check for this problem is to add those up. So let's take 72, 54, 144, and 90. Add those all up, and then what should they equal? If we have a nice pretty circle, add those up, and you should end up with 360 degrees, which will get us all the way around your circle. All right, now we need to actually put this into our circle chart here. So I'm going to do the best I can on my iPad here, but bear with me. So I'm going to set up my protractor in the center of my circle. So this spot right here, where these meet, that's where you should put your protractor, where the T is. So you always want to, you want to line up that T to be right at the center of your circle. Okay, so that's about as center as we're going to get. And our first one is 72 degrees. So if I'm starting here at 0, so this will be my first line. It'll be 0 degrees. I need to make my next line at 72, so I'm going to go all the way up until 50, 60, 70. And I'm going to go just past that. So my straight line will be from here to just past 70. Okay, just past 70. So this is going to be my tomatoes. Tomato at 72 degrees or 20%. And then next, I'm going to take this, and now I need to turn it so that I can line up my center with my next line. So I'm going to line up here, move this over. So again, I want my line to be, line up my center and line up so that my black line right here, we want those to overlap as best as we can. All right, so my next section is 54 degrees. So let's get rid of this little line here. I need to find where my 54 degrees are. So I'm going to start at 0 and I'm going to go to 50. So I'm going to want just before that halfway marker because that would be 55. And we're going to draw a line from the center to 55. Or I'm sorry, 54. Get my straight line here. Just below 54. Okay, so that next section, move my protractor out of the way here. Okay, there we go. This is my tomato, or vegetables. My root veggies. And that is 54 degrees and 15%. Okay, I'm going to do the same thing for 144, but now again I'm needing to line up need to line up my corner here, and then I need that to line up with my pink line so that I can get the most accurate reading that I can. So lining up the center, lining up on my pink line there. Yeah. There we go. All right, now I need to go to 144. So this is going to be a big angle, almost half. 40% is just under half. So we're going to go here. We're at 0 all the way around. So now we're at 110, 120, 130, 140, and we need to go just past that. So we should be at 144. So we're going to do our line from the center out to 144. Okay. All right. Move my protractor out of the way here. And that should get us pretty close to, see, 144, 40%. And that would be our melons and squash. And that means our last part here is going to be our Brussels sprouts at 25% and 90 degrees, which if you think of a fourth of 360 would be that nice 90-degree angle there. All right, so when you have your problem, you always want to do that out of 360 degrees. So you do whatever that percent is times 360, and that's going to be how much it is for each section. To check your work, you need to add them all up, make sure they equal 360 degrees.